Yes, so thank you, Jeff, for putting up with my crazy laptop that's currently doing an extended screen mode in order to work. So apologies for that. And thank you, Val, for getting the script together. We've been enjoying all the talk so far. And thank you, Pedro, for filming today's session. So, let's see. I'm Jeromy Anglim, and in preparation for this talk, I posted a lot of things on my blog. So, if any of the points I'm skipping over, you want to learn more, there's generally a link, and I'll post these slides at some point. So, there'll be either links in fine print at the bottom to an extended discussion, because I just basically, my audience on my blog is me 2 weeks before I write the post. So I write what I think I wish I knew 2 weeks ago, and you can learn a lot about R in 2 weeks. So that's my philosophy. Okay. Let's see. Now it's my turn to get. Okay, so I wanted to talk a little bit about a few tools that I like using, a little bit about workflow, how do you organize your code and functions, with a particular emphasis on Sweave and reproducible research. I particularly like John Chambers' book, if you ever want to get an understanding of the deeper philosophy of R. John Chambers, who invented S, the early, I guess, language of which R is a dialect, recently wrote a really good book called Software for Data Analysis Programming with R. I think this is a reference to Star Trek, but I don't know enough about Star Trek to actually know. But apparently the mission of us all is to enable the best and most thorough exploration of our data as possible. And the prime directive is that the computations have to be trustworthy, i.e. reliable. And I guess we all have our own approaches for thoroughly exploring data and making sure it's reliable and trustworthy, testing, these sort of things. But I guess R is a wonderful tool for achieving this broader mission and ensuring trustworthy code. Because it's open source, you can see the code and so on. Okay, there's many things you can do with R, and I find it's worth thinking about what is the final product that you're trying to produce. For me, it's often a report. It could be a journal article or a publication, like PowerPoint slides, or it might be just an informal report where I want to show the console output or something like that. Or it might be some batch report. You know, every unit of an organization needs their own survey results. You know, you deliver an opinion survey, and you know, there's 100 different units, and they all want their own individualized report, but it's a basic template. Another thing you might want to do is prepare a data set for multiple reports down the track, so you want a clean process documented. And I guess next time, Rory will be talking about software development and packages and things like that. But I wanted to talk just about this report bit of the workflow game. Okay, so when I first encountered R, coming from the world of SPSS and PowerPoint and Excel, and Windows, I had no idea where the makers of R were coming from. The philosophy behind R and the way it fits in really nicely with LaTeX and the way you use batch files and the way you run things from the command line, it was all foreign to me. So I was confronted with this question of, well, how do I divide my project into files and folders? How do I incorporate you know, figures and tables and text into, say, a report? You know, I used to copy and paste things from SPSS to Excel and then format it in Excel and then paste it into Word. That's not the way you do things in R and LaTeX and all that. So I had to learn all that. There's the challenges. How do you get your figures and your text into something pretty? You know, what if you want to have a production quality table? I mean, the default console output's not quite what you want. How do you build the final product? How do you sequence the analyses? How do you divide it into functions? These are the challenges I had. I don't know if other people find this as well, or whether it's sort of obvious to everyone but me. So yeah, how do I achieve the mission and fulfill the prime directive with all these things going on? So I first want to talk a little bit about workflow. There's been a fair bit of discussion on the internet, on Stack Overflow, on various blogs and forums. So I just wanted to talk briefly about a couple of the interesting ideas that are sort of out there. One post which was quite abstract, which I found useful, was by David Smith from Revolutions. He talked about 5 just general principles of organizing code to make it coherent and easy to understand. And I suppose this is kind of obvious. Organizing things into logical units, standardizing on a structure, on standard folders, standard file names, standard places to put, say, your library statements to install packages, standardize things for README files and so on. Make sure it's portable so that if you take your code to another computer, it will work, ideally on other operating systems or on anything. So that means things like relative paths and I guess minimizing just dependencies that you think are going to break anytime soon. Try and make it reproducible. So I guess this is like Jeff's idea of making sure your code sources directly from the data, so that there's a direct flow from source code, raw data, raw functions, raw LaTeX into something produced like a report or a product, and hopefully make it efficient and easy to maintain. So I thought they were useful general ideas. One simple philosophy for organizing your code in R is, well, I think there's this guy JD Long, he may even see this video, who called it the Josh Reich LCFD model of organizing the R code. And that basically says when you've got a new project, basically you have a script that loads your data, you have a script that cleans, processes, imports, creates new variables, converts things to factors if they need to be factors, deletes data, etc. Sorts out missing data. You have your external functions, and then you have something that calls whatever's required to produce the output. So that's kind of one way of organizing our code. Has anyone seen the project template package? Has anyone heard of that? Or so, if anyone's, well, when you already know, talk about, I think it's called package.skeleton, where you get a basic template for a package if you develop a new R software. John Miles White, whose blogs a fair bit about R, thought it would be nice to have a standardized system for developing documents and other sort of statistical projects that aren't full-blown software packages, but rather just a general project involving the use of R. So he has this package called Project Template, which you can download off CRAN, and when you run it, it will create a standardized template of folders and files, which is, it incorporates a lot of what you might call best practice ideas for organizing your code. Good things about it are that it makes it easy to start up a new project, setting up files and folders. It is standardized, so in theory, if more people adopted it, other people will be able to understand your code better. You have a standard folder for data, for storing your data files, for storing graphs, for storing external code in the lib, for storing test cases, for diagnostics and so on. And even just by having all those bits, it sort of actually encourages you to think, oh, what diagnostics am I using, or what test cases am I using? A nice thing it does is automates data loading. So I think if you can put any CSV or tab delimited data, or based on the extension, if you put it in the data, then you can run a function and it'll automatically import those data files into your workspace with the same name in R as the file name. So that could save a lot of time, especially if you have a lot of data files. Encourages you to have a README file that has little notes and to-do lists, encourages unit testing, and standardized placement of sort of calls to external libraries. So that's not bad. If you want to get involved with that, start using it, or even just check it out to get some ideas to how to manage your own projects, then you just go install.packages project template, load project template. Now have a look at the help if you want for project template. But basically, you create a project. You might call it My Project, creates a new folder called My Project with a bunch of subdirectories and files. And then once you've got your data in it, you just load project, and I think that will just load up the data.
Jerry,
yeah.
Sorry, you're going to come back to this later, but no, but you briefly mentioned on unit testing.
Yeah.
What's the best practice in unit testing?
Best practice in unit testing?
Is there kind of, do people use kind of a front end or libraries? Or
Yeah, there are. From memory, there's 3 packages that are popular or are used, and I've seen a little bit of discussion about it, and I haven't seen a consensus. There's StatET, I think it's called, by Hadley Wickham. Well, he wrote ggplot too, so he's a bit of a guru, so that's not a bad one. And I think it's one called RUnit, and there's one other that escapes my mind. My sense is that they're all pretty good, and the functionality is pretty similar, and the main thing is that you use one.
What do you do?
Well, in 2 weeks, I'm going to write something on my blog, and I'm going to tell everyone about what I didn't know now about testing. Yeah, in short, actually, it's something I would have liked to have got to in this talk, but I think, yeah, I'm still working it out, but it's very close to my to-do list. But yeah, test that in RUnit are the 2 I'm going to try. Yeah, John Miles White has a really good tutorial on his website, which just goes through a really basic example of test that and RUnit, compares the 2. Yeah, so anyway, that was workflow. So these are some good ideas for organizing your files and folders and code. I want to talk about a few things about some tools that I love in R to manage projects. So the first thing I guess you've got to decide when you start R is what environment do you use to write your code and run your code and so forth. I don't know. Who does use? What do people do? Do they use ArcGUI? Does many people here use ArcGUI? Yeah, a lot of people. Does anyone use Emacs and ESS? Yeah, we've got one in can. Does anyone use Eclipse here? TinR maybe? Just like Notepad and something else? Anyway, there's lots of IDEs and just script editors and things, and you can use it any way you like. What I wanted to talk about is Eclipse and the StatET plugin. So, although that's a picture that's hard to see, if it was easy to see, you'd see a beautiful IDE, which is Eclipse and StatET. Eclipse, I believe, is very popular maybe in the Java community. It's open source, it's free. I think it's open source. It's definitely free. I think it's sponsored by IBM in some way, or is it Sun? I don't know. Anyway, it's a very full-featured IDE. Some would say it's the exact opposite of a lightweight system. It has everything, all the bells and whistles. StatET is a plugin that enables Eclipse to understand R. You can have an R console. You can have an editing environment where you color codes. You can do code folding. There's a lot of really cool ways of sending code to the console. So Control R will send the line to console. Control R, Control 3 or something sends that command. So if it's multi-line, it will take all 3 lines and send it. Control R, Control F sends the whole function to R. Control R, Control S sends the whole file to R, etc., etc. So there's lots of really cool shortcuts when you're in a script to send code to the console, which saves time.
So that would support stepping through code, just like Eclipse does with other languages?
Yep. So one of the Control R, Control somethings runs the current line, then moves the cursor to the next command.
Do you find this is very stable? Is it I found it a little bit flaky when we say PHP?
Well,
advanced things, looking at watching variables.
Yeah. I admit occasionally I get like an error message, but I don't lose any code, and it usually just means clicking something and then it's back to normal. Yeah, I find the productivity benefits outweigh any of these couple of little things, and it's a little bit fiddly installing. But yeah, you've got all your files and folders organized into projects over here. You've got the queue of commands. You can do file search. You can have multi-tabbed files. You can configure external tools like I might have an external command to run a command prompt or a SH sort of prompt. You can configure all sorts of external commands. Anyway, it's full featured, lots of options.
Yeah. I've tried to use Eclipse a number of times in the past on half a dozen I don't know, is that?
Yeah.
And every time I decide I'm not clever enough to do it, I always get lost. I guess part of what loses me is this whole project thing.
Yeah.
So how do you get started when you start doing stuff in R?
Yeah, I have to say, what annoyed me for a while was, particularly on my old laptop, when it took a while for it to start, or on my new laptop it starts really quickly. If I want to just do a quick, let's have a look at something. I want to use R as a calculator, or I just want to load up a quick script or something. It's not all that good. Everything is structured around a project. So it assumes that you have a project that you're trying to do. So that you're trying to, say, build a document with code and things. So it assumes the sort of project
mentality. So you kind of have to start creating a folder, and then you put a file in it, and then you kind of create a project.
Yeah, well, what I do is I usually, I find a folder that I want to start my project in. I created it in Windows Explorer or whatever. Copy the address, go to File, New Project, and that's the directory for it, and it starts there. And then I'll start plonking in files like main.r for some main code, or an R&W file for a Sweave document, or a data folder. And I'll plonk all my files and folders in using this interface. But yeah, I think it does really encourage, even force, a project mentality. So if you're sort of doing a few little ad hoc sort of scripts, or you just want to create a quick figure, or you can have a little temporary project or something like that. But in general, it's really suited, I guess, when you've got a project of some sort.
One of the features is you can use long variable names, and it'll fill in. You just type the first couple of characters, and it'll fill in the rest.
Yeah, it has a lot of content assist features like that.
So, people who like long variable names quite often seem to like Eclipse.
Yeah,
because you can have the full description.
does that now too.
Sorry?
If you hit Tab in Arduino, it does that now.
Does it? Oh.
And if it's like, if there's a few things that start with that, it'll fill it.
It'll give you a choice.
You can hit Tab again. It's just like in Bash. And it shows.
Okay, thank you.
Yeah, so lots of good things in Eclipse, and lots of good things in the StatET plugin component of Eclipse. And yeah, some of those, it's got an object browser, so you can browse your workspace to see all the object names that are currently in your workspace. So you can even actually browse the installed, like the loaded packages you have to see all the functions that are in it, in an object browser. And, it's got lots of bells and whistles, and so do other programs, but this is one of them. So if you like bells and whistles, then Eclipse and StatET is pretty good. Anyway, if you want to know more, as I said, these slides will be up. So yeah, check out StatET website that has information. Long How Lamb's guides, a great PDF guide if you're interested in getting started with StatET and Eclipse, and I have my own little post. Okay, so yeah, a few tools I wanted to talk about, and I guess part of it's this project mentality to thinking about R. When I've started thinking, okay, if I want to build a document with some incorporated graphs and figures, that document is my final product, and that is, in a sense, a project or a coherent repository of data, code in R, and some sort of file that's going to, LaTeX file that's going to incorporate that figure and things. So that's a project. That can be put into a coherent repository, and so naturally, a good way to manage the changes that I'm going to see is with some sort of version control tool. I don't know, I've only just got onto the version control bandwagon. I don't know, do other people use version control? Yeah, I mean, clearly if you've got a computer science background, then I'm a laggard, but if you're someone like me in the psychology department, social sciences, version control, not everyone's using version control, it's a novelty. So for me, it's an enlightening moment to discover version control.
Do you want to enlighten us as well?
Okay, what is version control?
Maybe look it up online.
Yeah, sometimes it feels like you're entering the dark arts, kind of about the secrets or something. Basically, it is it's a system for monitoring all your files and folders in a repository, which for me just means, well, there's a folder on my computer with a bunch of folders and files and subfolders. And I create a repository on that folder, which represents, say, a project of data and R code and so on. And I commit changes. So I might say, okay, I've I've got the code to a certain level, I'll commit those changes. And then a permanent copy of that point in time is there. Then I'll go ahead and make some more changes, commit that, and then I go, oh, actually that last thing I committed, that's terrible. I want to go back to the original commit. I can go back to that. Yeah, I believe if you're collaborating with people, it's very easy to collaborate because you can both work on it, and then you can use various tools to merge the two streams. It's a way of, if you say sending a project off to a client, you can commit it at that moment and then make more changes and improve it, but you still got that earlier copy to roll back if you want to.
And is that something within R, or is it something?
Version control is just
just
a practice. I think it's typical for most computer programmers, and I guess R and LaTeX and Sweave makes you think about data analysis as a programmer. Yeah.
Oh,
So
yes, right. I don't see this.
But you use it in Eclipse, don't you?
yeah. So this is just. I mean, yeah. So what I'm going to. Version control was my first point. That it's a great tool to have, particularly once you have a project in R that you're working on. And I really found it useful for getting the distinction in my head between source and derived files, and thinking about dependencies, and trying to have a clean project with folders and files that sort of all interlock to produce some final product like a report. So that, even just the practice of committing changes, I found helped me think about R and the things I was creating, I don't know, just more coherently, I guess. I didn't have these little files just building up all over the place. Every file sort of had a purpose within a broader project, something like that. Perhaps other people had that experience when they first discovered it too. 10 minutes? Okay. So there's many version control systems, CVS, Subversion, Mercurial, I don't know anything about version control other than some people like Git. There's a cool kind of like social network site for coders where you can share your code, and Happy Wickham's up there, and John Miles White's up there, and all these other cool people. So you can load your repositories up to this site and share your code. So I've got involved with that, so that's one good thing about Git. Yeah, and as I say, some of the experts seem to like it, so I thought I'd start with that too. So yeah, Git, why not? If you're going to go down my track of Eclipse, then I think Egit is, I don't know, seems like a fairly easy way of getting started with version control. It's graphical, there's menus, you know, I think the hardcore people use command lines to commit their changes, but for me, learning, getting started, Egit, it just plugs into Eclipse and you've got a menu where you can, I don't know, commit your changes or add a file to your repository and so on. So yeah, it's not a bad option if you're into the Eclipse world. Yeah. One other tool I wanted to talk to, and I think this all sort of interconnects the version control and thinking about your project in a coherent way, is make and make files or something equivalent. I don't know, do people use make or make files or something equivalent? Yeah. So basic philosophy is that you want to have a one-click build. You want to have one button or one command that creates your thing, that takes the source code, takes the functions, takes your data, whatever it does, processes it all and produces whatever output you want. And for me, that's usually a PDF of, you know, a report analysing data with some tables, figures and text, or perhaps a bunch of reports or whatever. But there's going to be something that runs the R, or runs Sweave, or runs, you know, whatever, runs LaTeX. The make file puts those commands together, and then you can use that make file to build your project. And so it also, I think, forces you to think about how the bits and pieces of your project fit together. Okay. This is just a quick squiz at what a makefile might look like in a sample Sweave project. So for example, I have a variable output that takes a name.output, which will store some files where they will be processed, some other variables. Main point here is it has a goal, which is, in this case, I'm calling all. And so when I type make, or just run make through Eclipse, it will run Sweave on some Sweave file, which will produce a LaTeX file that has tables and figures integrated. And at some point down here, after copying these files and stuff to a location, it will run LaTeX on that tex file to produce the PDF.
And the Mac can coexist with the Eclipse, with the project and so on?
Yeah, so I have an external thing, like it just basically says run make in this project folder. So I go Alt-RE3, I do that all the time because Alt-RE3 means run the external tool make, and then that will just run the default goal. So whenever I'm typing code, Alt-RE3, then it runs make. If I want to run some other goals, like clean up the derived files, I might type in the shell make clean, and that would remove all the derived files. Or if I want to back up the copy of the PDF to another folder, I'd write make backup. But anyway, if you're curious, yeah, I've got a little post.
You're doing this in Unix?
Oh yeah, so in order to use make on Windows, you just install RTools. So that's, Roy might even talk about that, because if you want to make packages on Windows, you need this free thing called RTools. I think is it Duncan Murdoch? Someone just supplies this set of tools that has, I think it's tools like Cygwin and you know, make and a lot of LaTeX, sorry, Linux tools, C compilers, etc. Whatever you kind of need. Yeah. So if you install RTools, you should have make. But yeah, with all these things, I've got some further notes about it. You know. Basically, once I learn it, I write it up. Yeah, if you're curious, you can read more about it. Yeah, so in terms of actually building documents, this is probably finish it up here, is to say Sweave is a really good tool. Does anyone use Sweave? A few nods. So Sweave is probably the main tool for using R to write reproducible research, i.e. to integrate LaTeX with R code chunks. So you basically write your LaTeX and then issue a command and put in your Sweave. The key benefits are is that the document and the source code are sort of interconnected so that the document is reproducible and there's a close association between text and the analyses. It's really cool, in short. It's really, really cool. Maybe I'll just, have I got three or 4 minutes? Yeah. Okay. So there are different types of Sweave documents you might make. So I'll just, before I show an example of Sweave, I just want to say kind of some of the types that I've sort of thought about. And this might fit into the kind of things you do in your data analysis practice. One is what I call like a console report, which basically means you're writing a document and you want to insert into your document, okay, here's the commands that I've run in R. You know, I've run LM on a linear model on some stuff, or I've loaded this library. So you want to show that code in your document, saying, so you've got normal text, and then you say this is the console input. And you might want to show the console output. You know, that raw text R output that's pretty ugly, but if you're an expert or you know R, then you can understand it. So that's kind of one type of report you might want to do in Sweave. Another is batch reports. So you want to churn out 200 reports, one for each unit of the organization. They're all the same, but with a little bit different, you know, different data. You can do that quite nicely with Sweave. You can do database-driven documents. So basically, you're creating LaTeX in some way through R. And finally, journal articles, polish reports, polish figures, polish LaTeX tables. You don't want any console input or output. You just want to have polished figures, polished tables, and results integrated. So they're kind of the 4 kind of reports that I've sort of thought about. And I won't go into this all now, but I'll show perhaps just briefly one example. But I've got basically 4 examples of one example of each of these types of reports with a blog post associated with it and all the code available on GitHub if you want to inspect to see what a project looks like with the make file and with the RNW Sweave file and with the data and folder structure and so on. So just to give you maybe 2 minutes to give you a flavour of what this might look like in Eclipse. Well, it's a little bit like what it might look in Eclipse. So let's have a look at maybe. Okay, so it's a little bit tricky to see, but basically this was an analysis of multiple choice test where we had respondents with some. Some data, some metadata on the items, a git ignore file to tell what data to ignore. We've got a make file that builds the project. I guess I can go to Alt RE3, and then we're going to presumably run the Sweave. And then you never know, you might even produce a report. A bit like that. And you can have a look at this code, but basically you've got LaTeX tech, LaTeX, then console input, all the LaTeX commands, and so on. Yeah, so this is an example of what I would call a console report, where it's just for you or for someone who knows about R, and it's produced a PDF with the LaTeX and the R code interspersed, where the R code has been substituted with console input and console output. Yeah, so just to give you a very brief flavor of. So we look a little bit like this. So you've got LaTeX, and then you've got R code chunks with a name, and then some R code. And basically that R code when it gets run, and gets substituted for the results that it produces. Anyway, I could go on about Sweave and R a lot longer. I think Eclipse is a really nice environment for working with Sweave and also with R. But of course, there's many other tools. But yeah, if you want to learn a little bit more about Sweave and R and how one person, i.e. me, manages the Sweave projects and incorporates make files and version control and so on, then have a look at a couple of these examples. I'll post these notes up on the website. But anyway, yeah, thank you for all your time, and yeah, that's my introduction.
Thanks, Jeromy. Thanks, Jeff. I think these kind of sessions are great. That's what user control is about. Seeing how we do things and being able to talk and interact. More of these. That's it for this year. So as I said, the next meetup will be a very informal one in January and then a very informal one in February. Have a great break, a great Christmas break of the year. Those of you staying on, let's go and get something to eat. Let's get